Hello, welcome to GMAT GENIE Number System Part 3. Today we will be looking at how to find out the number of zeros in any expression. Before we start, please note down the website address. It is www.gmatgeniscore.com and the email ID is gmatquant@gmatgeniscore.com. I'll repeat, email ID is gmatquant@gmatgeniscore.com. So let's look at the number system, how to find out the number of zeros in any expression. So we know that zeros are formed by the combination of 5s and 2s in any expression, right? So let's say you need to find out how many zeros are there in 4 times 10, right? So you find out the number of 5s in it. So 10s has got 1 5, and then number of 2s are 3s. There are 2 2s in 4 and 1 2 in 10, right? So you find out the lesser of these two, that is 5 and 2s, right? So 5, there is only 1 5, and then there are 3 2s. So you take the lesser of these two quantity or numbers, so 1 5 and 1 2s, right? And you get 10. So you say that it has got only 1 0 in it, right? Let's illustrate this with some example so that you are able to better understand it. So let's take an expression 45 times 36 times 78, and we need to find out the number of zeros in it. The above expression can be written in the form of 3 times 3 times 5, which multiplies to 45. Similarly, 36 can be written as 2 times 2 times 3 times 3, and 78 can be broken down in 2 times 3 times 13. Now we need to find out the number of 5s in this expression and the number of 2s in this expression. We notice that the number of 5s is 1 and number of 2s are 3 in this expression. So we can only form 10 with only 1 5 and 1 2, because the number of 5s is less than the number of 2s. And we also notice that there are 3 2s in it, in this given expression, which is more than the number of 5s. So we come to conclusion that we have only 1 10 or 1 0 if we multiply all the values in this given expression, as there is only 1 5 in this given expression. So we can safely assume that number of 5s in any expression will dictate how many zeros are there in that given expression. Let's take one more example to illustrate this concept. Let's take a big expression. We are going to look into a factorial 49. We all know factorial, what factorial is, right? For example, factorial 3 is written as 3 times 2 times 1. Factorial 4 is written as 4 times 3 times 2 times 1, right? So let's find out the number of zeros in factorial 49. Factorial 49 can be written as 49 times 48 times 47 times 46 up to 5 times 4 times 3 times 2 times 1. It goes on till 1, right? So you have approximately around 49 numbers in it, which are multiplied to each other, starting from 1 it goes up to 49, or in a reverse manner, starting from 49 it goes up to 1, and all of them are multiplied. Now we need to count the number of 5s in this expression. We see that 5 is repeating in this expression after every 5th number. So in this case 5 is there in 5, 10, 15, 20, 25, 30, 35, 40 and 45. So we count the number of 5s in this expression. So totally we get 10 5s are there. Please note here, we have counted 1, 1, 1, 1, and then for 20 we are for 25 we are counting 2s. Why is it so? Because 25 has got 2 5s into it, so we have to count it twice, 2 times, right? So there are total number of 10 5s are there in this expression. We also see that there are abundant number of 2s in this expression, as 2 would be there in every second number in this expression. So number of 5s are much less than number of 2s. So we can safely conclude the number of zeros in this expression would be dictated by the number of 5s in this expression, and so the number of zeros would be 10. What happens if we need to find out the number of zeros in factorial 50? We will have to add 2 more 5s into the above count. And why is it so? Because factorial 50 would start from 50 and it goes 50 times, 49 times, 48 times, 47, all the way up to 5 times, 4 times, 3 times, 2 times 1. And you will note that 50 can be written as 2 times 5 times 5. So 50 has got 2 additional 5s into it. So the total count of 5 goes up from 10 to 12 because there is an additional number which is 50 in this whole multiplication. So we can conclude that the number of zeros in factorial 50 would be 12. Now let's work out a problem. Let's take a number which is more than 100 and let's find out how many zeros will have this expression. So let's take a number. Let's take a number called factorial 168. So factorial 168 can be written as 168 times 167 times 166 all the way up till 5 times 4 times 3 times 2 times 1, right? Now if we were to find out the number of 5s in factorial 168, we will see that 5 is repeating at every 5th number. So here you have 1 5, then you will have in between you will have 10, right? There you will have 1 5. Similarly you will have 15 where you will have 1 5. Then at 25 you will have 2 5s. Then 50 will have again 2 5s. 75 will have again 2 5s, right? 100 will have again 2 5s, and then when you come to 125, that right, 125 will have 3 5s, okay? And then of course 4 5s will only come when you have 625. So, but here we have factorial 168, so the maximum number in this expression is 168, which is less than 625. So we don't need to worry about anything beyond 168. So how do we get the number of 5s here? So the easiest way to do that is you divide 168 by 5. It will give you all the number of 5s, okay? Then you have additional 5 at every 25th number, right? So what you do is to capture that additional 5, you divide by 25, okay? Then as I said, 125 will have 3 5s in it, right? So to capture that additional 5 in 125, right? So the second 5 will be captured using this when you divide by 25. The third 5 in 125 would get captured by if you divide by 125, right? Now all that you need to worry about here is only the quotient, not the remainder. So if you divide 168 by 5, you get 3, and then you get 33. 33 into 5 is 165, which is less than 168. You get a quotient of 33 and remainder of 3. So you need not worry about remainder. So it has 33 5s in it. Then if you divide by 25, you will get 6 as a quotient and remainder would be 18. So 18 is less than 25. So you don't have to worry about that. So it will have additional 6 5s. And then 168 by 125 is 1. Right? That is a quotient and remainder would be 43. That you need not worry about. So the total number of 5 in factorial 168 would be 33 plus 6 plus 1, which comes to 40. Right? So the total number of zeros in factorial 168 would be 40. Isn't it a very simple way to do it? Instead of multiplying using calculator or some other means, you find out a very huge large number and then you figure out the number of zeros. This is a much more simpler and a very handy tool to figure out the number of zeros in a very large expression. I consider factorial 168 as a very large expression. So beat any number in the world, you just go on dividing the way we divided 168 by 5 and then 25 and then 125. Suppose that number is 640, factorial 640. Then of course you will also divide 640 by 625, right, to get an additional 5s. So this is one of the most easiest and simplest way to find the number of zeros in any given expressions. Okay, hope you enjoyed this tutorial. If you still have got any query, you can write to us. Our website address is www.gmatgeniescore.com and our email ID is gmatquant@gmatgeniescore.com. Thank you.